Hello guys, and welcome back to this one. Today we are just going to be looking at something simple, and it's going to be like a continuation of what we did yesterday. So yesterday, just as a reminder, we did a cyclic, whether a singly linked list is cyclic, right? Just as we had here, and then we went ahead to show this here. Now we used the method, right, where we went like a carousel, and we found the what's it called, the cycle, the cycle starts, as we named it here, right? The cycle starts, or wherever our list comes back to create a cycle at, right? And we did that here from yesterday's video. But one thing we found that was that O of n was n squared, and that was because we were calling a while loop that was going through all the node, and a search that at the worst case would search through the entire load in a linear sense, and that was compiling to O of n squared, right? Now this is a bit of an optimization, right? And it's a significant one because we get rid of an entire O of n and we use a set. Now by using a set, what does that give us? What leverage does that give us? Now set lookup is O of 1 on average, so each node is checked once. So basically, why this for current in this thing, if current in scene nodes, basically because this scene nodes is a set and not a list, we have a search of O of 1 rather than O of n, of going through the list one after the other. So the way sets work under the table, under the hood, is like a hash table. So basically it has like instant searching and finding, right? And basically that's what we have here. So we will see that we will see here the complexity, right? Say set lookup is O of 1 on average, so each node is checked once, right? And then obviously we go ahead to also look at the storing, the complexity of storage, right? Because our set is still holding the full length of all the nodes that the list has to give, therefore we are still holding O of n in that sense. So that's basically it for this one. It's just basically the same thing with yesterday's video where we saw the recursion go through the node, and we printed out the value. But just what I wanted to highlight today was simply this little tweak in complexity that could help us an entire system become more more effective and basically more efficient, right? Because a removal of O of n is huge. It's huge, especially when you're dealing with large data. And basically that's it for today. Muchas gracias. Auf Wiedersehen. Tschüss.